Hi, and yes, as the heading says, there's no avoiding Pythagoras. His formula seems to be everywhere. Do you know what that formula is? The Theorem of Pythagoras. We have a right-angled triangle. The three side lengths are A, B, and C. And the formula, according to Pythagoras, that relates to the three sides is given by C squared equals A squared plus B squared. Have you heard of the cosine rule? It relates to non-right-angled triangles, like that. We have our three sides again, A, B, and C, and an angle between two of the sides, in this case between sides A and B. And the formula that relates those three sides with the angle is C squared equals A squared plus B squared minus 2AB cos theta. Do you notice something? Pythagoras' formula seems to be embedded in the cosine rule, doesn't it? Let's prove it. There's the cosine rule. Let's suppose we have a right-angled triangle. That means the angle will be 90 degrees. Therefore, we have cos theta equals cos of 90 degrees. And of course, that represents a right-angled triangle. Cos of 90 degrees is always 0. So replacing cos of 90 in the cosine rule by 0, we have C squared equals A squared plus B squared minus 2AB times 0. And of course, that gives us C squared equals A squared plus B squared, which is Pythagoras' formula. Pythagoras' formula or theorem is actually a simplified case of the cosine rule when the angle is 90 degrees. The area of a triangle. I'm sure you know that the area of a triangle is a half times its base times its vertical height. But what about if you only have two sides and an angle between them and you do not know the vertical height? There is a formula that gives you the area. There it is. They're the two sides and the angle between them. And the formula for the area A of the triangle is given by a half AB sine theta. Now let's use that property to prove something that seems totally ridiculous, that every triangle has an area of 0. We'll start with our formula for the area of a triangle, a half AB sine theta. Multiply both sides of the equality symbol by 4 and we have equation number 1. Now this is our cosine formula previously. Rearranging it, we have, as you can see there, what I've called equation number 2. Now let's join the equation number 1 with equation number 2 by dividing. We'll divide equation number 1 by equation number 2 and that's what it looks like. Notice on the right hand side we have 2AB on the top and 2AB on the bottom. We can cancel those. And also we have in the numerator sine theta and cos theta in the denominator. This is a standard trigonometric function. Sine theta over cos theta is always the same as what we refer to as tan theta. So simplifying all of that, this is what we have. Now rearrange that to get A by itself, and that's what we have there, as you can see. Do you notice something about the expression in the brackets, A squared plus B squared minus C squared? It reminds us of Pythagoras' formula, doesn't it? There's Pythagoras' formula, and with a slight rearrangement, you can see that we can write it also as A squared plus B squared minus C squared equals 0. So in fact, the expression in the brackets in the previous line, we can replace by 0, and it looks like that. And of course, that simplifies to A equals 0. Now we know this can't really be the case. By definition, every triangle has an area. So what went wrong? Where is the error or the misjudgment? If you can work it out, please let me know. Until next time, bye-bye.